Hello everyone, welcome back to AI for Product Managers Ep.6. I am Pranav Harish, and today we are going under the hood of the technology that's reshaping every product category. That is called large language models, LLMs. This is phase one of our series, Foundations, and this episode is the one you'll keep coming back to. So let's deep dive in. So here is the uncomfortable truth. Every PM is using ChatGPT or Cloud or Gemini today, right? Almost none understand how it works in the background. So that's a product risk, I believe. So look at these numbers. 4.2 billion spent on LLM APIs in 2025, and 92% of PMs use AI tools daily, but less than 15% can explain how they actually work, right? You are probably making a product decisions about LLMs right now, or you will be soon tomorrow, right? Without really understanding the fundamentals that changes today. In the next 35 minutes, I'm going to give you a complete mental model for how LLMs work, the key concepts that the key concept that drive every product decision, and practical frameworks for building with them. So no jargon, no math, just what you need to make better product decisions. So let's go. So here is our roadmap for today. 7 things you will walk away with. 1. What LLMs actually do, no math required. 2. How LLMs are trained, the three-stage process. 3. The tokens, context windows, and temperatures are explained. And 4 is why LLMs hallucinate and how to mitigate them. And fifth one is LLM cost structure and unit economics. Sixth, when to use LLMs versus traditional ML. And final one, the evaluation, how to know if your LLM output is good or not. Okay, so this is the episode you will reference every time you are scoping an LLM feature, when you are scoping an LLM feature. So let's start with the basics. So what is a large language model, LLM? Let me give you the simple definition first, then the analogy that makes it stick, right? So a language model is a software system that has read most of the internet and learned patterns in human language. Okay, so when you give it a text, it predicts the most likely next word, technically the next token. Okay, given everything that came before it, then it predicts the next one and the next one, so until it's generated a complete response. Okay, that's it. At its core, it's the world's most sophisticated autocomplete. Your phone's keyboard predicts the next word to write. So an LLM just does it at scale and quality that feels like intelligence. Okay, so here is the analogy I use. Imagine someone who has read every book, every article, every website, every piece of code ever written in human history, right? They have absorbed all of it. Now you ask them a question, they can't reason from first principles. They can't actually think, but they can predict, right? With some remarkable accuracy what text should come next based on all the patterns they have seen. Okay, so four key points on this slide is: first, trained on internet scale text, books, websites, code, conversation papers, conversations papers, trillions of tokens, right? And second is pattern matching at scale. It doesn't understand, it finds statistical patterns in language. Okay, third is probabilistic output. It generates the most likely next token, not the most correct. Okay, fourth, knowledge frozen in time. It only knows what was in training data and has a cutoff date. Okay, and why does this matter for PMs? Because it explains both the magic and the failures. It explains why LLMs can write beautiful poetry but can't reliably do arithmetic, right? So why they can summarize a 50-page document but might invent a citation that does not exist. The capabilities and limitations both flow from this one insight. Okay, it's predicting likely text, not the reasoning about the truth. Okay, keep it in mind. Now let's get into the key concepts every PM needs to understand. First up is tokens. Tokens are the fundamental unit of LLMs. They are pieces of words, not exactly the words, not exactly the characters, something in between words and characters, right? So the word hello is one token. The word ChatGPT gets split into three tokens. Okay. On average, in English, one token is about three quarters of a word. Okay. So 100 tokens is roughly around 75 words. Why do you care? Because tokens drive everything in your product economics. Look at the left card. What what are tokens? Word pieces, not whole words. Chart GPT equals three tokens. Okay, one token is approximately 0.75 English words. Okay, and code is more token dense than natural languages. Okay, now the right card. Why token matter for PMs? Pricing is per token, right? Both input and output. Context limits are measured in tokens. Longer prompts equal higher cost, and token count affects response speed as well. Okay, and let me make this concrete with the examples at the bottom. Hello, how are you? Is one sentence is six tokens. This quick brown fox jumps over the lazy dog is nine tokens. And a typical 200 word email is about 260 tokens, right? Now this consider this entire slide deck script, roughly around 15,000 tokens. Okay, here is your maybe you can go to platform uh, openai.com/tokenizer, paste in a real user message from your product and see how many tokens it is. Okay, then do the math for your scale. That number will change how you think about the feature design. Okay, second key concept is the context window. Think of it as the model's working memory, everything it can see and consider at one time. Okay, the context window includes everything: your system prompt, the conversation history, any documents you have injected, right, and the model's response. All of it has to fit within the window. If it is doesn't fit, the model can't see it. Okay, it's not summarized or compressed, it's just gone. Okay, look at the comparison cards on the screen. GPT 4 gives you 1,28,000 tokens, roughly 96 pages of context. Cloud 3.5 offers 2 lakh tokens, about 150 pages. Gemini 1.5 Pro goes up to 1 million tokens, that's around 750 pages. And Llama 3.1 matches GPT-4 at 128K. Okay, tokens. Now here is what matters for product design. The why this matters for PMs. Okay, section at the bottom. First, it determines how much info you can feed in. Second, longer context equals higher context and latency. And third is, and this is subtle, right? The lost in the middle problem. Research shows that LLMs pay more attention to the beginning and end of their context window. Information buried in the middle is more likely to be missed. So, the context window is your product's fundamental constraint. Every feature you built with an LLM needs to answer the question, right? Does this fit in the window? And if not, what's our strategy? That's the question. The third key concept, the temperature. This is the creativity versus consistency dial, and it's one of the most important product decisions you will make. Temperature is a number, typically between 0 and 2, right? that controls how random the model's output is. At each step, the model calculates the probabilities for every possible next token. Okay, the temperature controls how it picks from those probabilities. Look at these three cards on the screen. Low temperature 0 to 0.3, deterministic, factual, consistent responses, best for data extraction, classification, fact-based Q&A, and code generation. Same input gives you the same output. Okay, and medium temperature 0.5 to 0.7, balanced creativity, good for most tasks, best for email drafting, summarization, and general chat assistance. The output sounds natural, not robotic, but stays coherent. High temperature 0.8 to 2.0, creative, varied, unpredictable output, best for brainstorming, creative writing, idea generation, and marketing copy. The model takes more risks, some brilliant, sometimes brilliant, sometimes incoherent. Right? Here is the PM decision at the bottom of the slide. What temperature is right for your use case? Okay, the right temperature depends on your users expectations. If they are asking for a legal summary, they want temperature 0. If they are asking for marketing tagline ideas, they want temperature like 1.2. You might even want different temperatures for different features within the same product. Okay, fine. That's, yeah, fourth key concept, hallucination. This is one that keeps PM up at night, and rightfully so, right? Hallucination is when the model generates the text that sounds confident and plausible but is factually wrong or completely made up. And it does all of this with the same confident tone as when it's being accurate, right? So, why does this happen? Four reasons on the screen. They predict likely text, not truthful text. The model optimizes for plausibility and not for accuracy. Two is no access to real time information. Okay, knowledge is frozen at the training cutoff date. Three is can distinguish fact from fiction. Training data contains errors, contradictions, and fiction. Four is confidence does not equal correctness. A does not equals to correctness. A hallucinated answer sounds just as confident as correct one. Okay. Now look at the real world example on the screen. June 2023. Um, a New York lawyer, Stephen, used ChatGPT for legal research. It cited six cases that didn't exist. Okay, he filed the brief. The court sanctioned him some $5,000. Okay, hallucinations have some real consequences. The PM implication at the bottom is critical. Never trust LLM output without verification for critical use cases. Build guardrails, citations, human review, and drag into your product. Your job is to classify every LLM feature on the risk spectrum and design it accordingly. Okay. Now let's talk about the money part. This is where a lot of PMs get surprised. LLM costs are fundamentally different from traditional software costs, right? Top left card, input versus output tokens. Input tokens are cheaper. That's your prompt. Output tokens are a bit expensive. That's the model's reply, right? Output costs 3 to 4 times more than the input. Longer output means much higher bills. That's a product design decision. Do you want verbose responses or concise ones? That you need to decide. Top right card, you can see pricing snapshot for 2025. GPT-4, they cost $2.50 for input, $10 output per million tokens, and Cloud 3.5 Sonnet, $3 for input, $15 output per million. Um, GPT-4 Mini, just $0.15 for input and $0.60 per output per million. Great for simple tasks. Okay. And Llama 3.1 self-hosted is just your infrastructure cost. Okay. Now the cost example at the bottom, customer support bot around like 1000 user times 10 queries per day times 500 tokens average per query equals 5 million tokens per day, right? Input cost is like $12.50 per day. Output cost is $25 per day. So monthly total roughly comes around $1,125 for 1000 users. That's around $1.13 per user per month. Okay. So the question for PM is $1.13 per user per month sustainable for your business model or not? Okay. What happens at 10x scale? Model your token economics before you build. Okay, this should be in every PRD for an LLM feature. Okay. Now let's talk about prompt engineering. That skill that separates PM who get um, mediocre AI outputs, okay, from those who get the great ones, right? This is just the intro. Every in episode 16 is our full prompt engineering masterclass, but I you just need the basics now, okay? So there are some four key concepts to a well structured prompt. Let's walk through each card on screen. First is the system prompt. This sets the model's behavior, persona, and constraints. For example, you are a helpful customer support agent for Acme Corp. This is where you define who the model is and what rules it follows. As a PM, you will spend a lot of time crafting and iterating on system prompts. Second, the user prompt, right? This is actual question or instruction. It's what your product's user type or what your app sends programmatically. Okay. The quality of the user prompt directly impacts op- output quality. Okay. Third is few short examples. You show the model what you want with 2 to 3 examples of ideal input output pairs. This dramatically improves output quality and consistency. Okay. It's like showing a new employee examples of good work before asking them to do it by themselves, right? Fourth is chain of thought. You ask the model to reason step by step before answering, something like think through this step by step before giving your final answer. This improves accuracy on complex tasks significantly. Okay, so remember, this is just the intro. Episode 16 goes deep on advanced prompting techniques, prompt templates, and evaluation. But these four components are your foundation. So, important reality check: LLMs are not always the right tool. Um, Sometimes traditional machine learning is better, cheaper, and more reliable, right? So, here is how to decide. In left column, LLMs are the best for text generation and summarization, flexible classification, conversation and chart, code generation and analysis, translation and transformation, basically anything involving the natural language. Okay. The right column, um, traditional ML is best for structured data prediction, recommendation engines, time series forecasting, anomaly detection, image and signal processing, basically anything involves patterns in numbers. Okay. Now look at the decision rule at the bottom. Is your problem about language or text? Use an LLM. About patterns in numbers, traditional ML is the best. Need flexibility and generation, LLM. Need precision, speed, and cost control, then traditional ML. Okay, the sweet spot for many products, use LLMs for the natural language interface and traditional ML for the core production engine. A fraud detection system might use a traditional model for the actual fraud scoring, but an LLM to explain the decision to a human reviewer in natural language. Best of both worlds. Okay. When you are building with LLMs, your product will typically follow one of five design patterns. Knowing which one you are building helps you make better architecture and UX decisions. Okay, let's go through each one on the screen. Pattern 1: Chat interface. Direct conversation with users. Examples: ChatGPT itself, customer support bots. The UX challenge is managing user expectations about what the AI can and can do. Pattern 2: Summarization and extraction. Condense long content or pull structured data from unstructured text. Examples like meeting notes, contract analysis. The value prop is saving humans hours of reading time. And pattern 3: Content generation. Create new content from prompts. Examples: marketing copy, code generation, report writing. The challenge is quality control and brand consistency. Okay. Pattern 4: Classification and routing. Categorize inputs and route to the right handler. Examples: ticket triage, intent detection. This is often the highest ROI pattern because it's invisible to users but dramatically improves the operations. Okay. Pattern 5 is RAG, retrieval plus generation. Ground LLM responses in your own data. Examples: internal knowledge base, document Q&A. This is most popular enterprise pattern in 2025, and we are going to explain it in detail on the next slide. So pro tip is most successful products combine multiple patterns, right? A customer support product might use classification to route, RAG to answer from docs, and chart for complex escalations. Now, RAG. Let us discuss on RAG, retrieval augmented generation. It is the most popular LLM pattern in 2025. Let me explain it in simply in 4 steps. Step 1: User asks a question. For example, what's our refund policy for enterprise clients? This is a question that base LLM can't answer because it doesn't know your company's policies, right? Step 2: Search your knowledge base before sending anything to the LLM. Your system searches your documents using vector search to find the most relevant snippets. It finds your actual refund policy document. Step 3: Feed docs plus questions to the LLM. You combine the retrieved context, the relevant document snippets, with the user's original question and send both to the LLMs. Okay. Step 4: LLM generates a grounded answer. The model answers based on your data, not its general training, right? The answer is accurate because it's grounded in your verified documents. So why RAG? Look at the green callout at the bottom. It reduces hallucination because the model answers from your data, right? Your company policies, documents, uh, it will take the answers from your data only, internal data. It uses proprietary data without needing to retrain the model, and it requires no fine tuning at all. You can set it up with any off the shelf model. Okay, this is how you build chart with your docs feature. So episode 18 is our full deep dive on RAG architecture, so don't miss it out. Now that you understand the key concepts, let me explain how these models get built. So these are 3 phases, and understanding them helps you understand what's possible with customization, right? The subtitle says it well, like it's like teaching a child language, then manners, then preferences, right? Stage 1 is pre-training. Read the internet, the company, OpenAI, Anthropic, Google, Meta trains the model on trillions of tokens, books, websites, code papers. The model learns grammar facts, patterns, everything, right? Cost is around 10 million to 100 million or more, right? Time is weeks running on thousands of GPUs. The result is a raw base model that can predict text, but it is unaligned. Okay. And stage two, fine tuning or SFT. Learn to follow the instructions. They take the base model and train it on the curated question answer pairs. Here is the question, here is a good answer, like that. So this teaches the model to be an assistant, much cheaper, 10K to $1 million. It takes days, not weeks. Okay. Stage three, reinforcement learning from human feedback. Learn what humans prefer. Humans rate the model outputs. The model learns from those outputs. Be helpful, be honest, be harmless. This is what makes ChatGPT feel safe and aligned. It's expensive, but it needs human labelers. Okay. So, why does this matter for PMs? Look at the callout at the bottom. PMs can do stage one, that's for big labs, okay? But you can participate in stage two, fine tuning a model on your data for your use cases is accessible and affordable as well, right? So episode 9 deep dives the build versus buy versus fine tune decision. So let's take a look into that episode in deeper. Let's continue to the next slide. Let's briefly touch on the architecture that made all of this possible. The transformer. This is the 2017 breakthrough that enabled ChatGPT, Cloud, Gemini, all of them, right? The key innovation is the attention mechanism. Look at the example on the screen. The cat sat on the mat because it was tired. When the model reads this, attention asks, what does it refer to? The model learns to focus on most relevant words. In this case, cat. Okay, that's the core idea. Now look at the before and after comparison. Before transformers, we had RNNs, recurrent neural networks, right? They read text one word at a time, forgot earlier context easily, couldn't be parallelized. We are slow to train and hit a quality ceiling at small scale, right? After transformers in 2017, the model sees all words at once. It decides what to focus on dynamically. It massively parallel, which means faster training. It scales with more data and compute, and it unlocked GPT, Cloud, and Gemini now. Okay. The call out at the bottom is like the original 2017 paper was called Attention is All You Need, and it changed everything. You don't need to understand the math, but knowing that attention is the key mechanism helps you understand why these models are good at understanding context and relationships in text. Okay. Now let's talk about five models every PM should know in 2025 and 2026 and when to pick each one. This is the comparison table on screen. So GPT-4 from OpenAI, closed source, strength, best ecosystem, fast iteration, best for general purpose and prototyping. Watch out for cost at scale. Um, Cloud 3.55 from Anthropic, closed source, strength is long context, safety, and coding. Best for enterprise and regulated industries. Watch out is like slightly slower than GPT-4. Gemini 1.5 from Google, closed source. Strength is multimodal with massive 1 million token context window. Best for video, audio, and huge documents. Watch out is like newer and less polished. Llama 3.11 from Meta. Open source, strength is free, self host, full data control. Best for privacy critical applications and heavy customization. Watch out is you need infrastructure to host it. And Mistral is open source, strength efficient, EU based, good multilingual support. best for cost sensitive and EU compliant scenarios. Watch out is smaller ecosystem. The PM decision framework at the bottom, evaluate on 5 dimensions: cost, privacy, quality, latency, and vendor lock in. My recommendation is to start with GPT-4 or Cloud for prototyping, then evaluate whether you need to switch based on your specific needs. Okay. Now, if you can't measure the quality, you can ship with confidence, right? These slides give you the evaluation framework every PM needs. 6 quality dimensions to measure: accuracy. Is the answer factually correct? Relevance. Did it actually answer the question asked? Coherence. Is the response well structured and logical? Safety. No harmful, biased, or toxic content. Latency. It is fast enough for your UX. Okay. Cost. Is it within your economic unit economics budget? Now, how do you actually evaluate? So, two approaches on the screen: human evaluation, the gold standard for nonce quality. It's too slow, expensive, and hard to scale. Use it early in product development and for spot checks in production. Have humans rate outputs on your quality dimensions. Okay. Automated evaluation or LLM as judge. Use a stronger LLM to grade the outputs of your production model. It's cheap, fast, and scales to thousands of evaluations. Combine it with golden datasets and regression test sets. Regression tests. Okay. The call out at the bottom is crucial. Build an eval set before you ship. It's your safety net for every prompt change. Every time you modify a system prompt or switch models, run your eval set to make sure quality didn't regress, right? This is the discipline that separates hobby projects from production AI products. Okay. Now let's look at what's actually working in production. 4 case studies that teach us different lessons about building with LLMs. GitHub Copilot, over 100 million in dollars in annual recurring revenue. It uses the Copilot pattern. AI suggests, developer decides. Trust is earned through the tap to accept UX. The lesson is inline assist beats chart for specialists. Okay. Don't force a chart interface when inline suggestions work better. Okay. Notion AI, $10 per user per month as an upsell. Generation plus summarization built directly into your documents. It's AI as a paid feature on top of an existing product, not a separate app. The lesson is AI can be pricing lever for your existing product. And Duolingo Max, $30 per month premium tier, role play conversations, and explain my answers feature. Premium AI equals pricing power. The lessons: AI unlocks a new ARPU tier that users will pay for. Klarna AI Assistant, $40 million in savings per year, and handles two-thirds of customer service charts. Replaced 700 agents in scope. The lesson is the cost reduction is a real and massive LLM use case. The common thread at the bottom is clear use case, tight workflow integration, and measurable ROI. So every successful LLM product has all three. Okay. So I have watched all 5 of these skill real projects. Don't be that PM. So let's go through each one on the screen. Mistake one: treating LLMs like deterministic APIs. Why did the output change today? Because it's probabilistic, right? Before build for variance, not certainty. Same input can give different outputs. Your test and your UX need to account for this. Okay. Make mistake two: ignoring cost at scale. Like $0.009 per call sounds cheap. Multiply by 10 million calls per month and your CFO won't be smiling on it. Okay. So always model costs at 10x your current scale before shipping it. Okay. Mistake three: no fallback for failures. The API goes down, output is garbage. Okay. Latency spikes. What does your product do? Nothing. is not an answer. Okay, build graceful degradation into every LLM feature. Okay, mistake 4, weak or zero evaluation, shipping prompt changes by vibes. Build an eval set, run regression tests on every change. If you can't prove the new prompt is better, don't ship it at all. Okay, mistake 5, using LLMs where simple rules would work. Okay, is this email spam? Doesn't need a $0.01 LLM call when a regress catches 95% of it for free. Okay, use the right tool for right job. LLMs are expensive hammers. Okay, not everything is a nail. The warning at the bottom is the biggest one is shipping LLM features without a kill switch or fallback. Always have a way to turn it off instantly if things go wrong. All right, let's close strong. Three sections on the final slide. First, your homework. Three things to do before episode 7. One is use the OpenAI tokenizer. Go to platform openai.com/tokenizer. Paste a real prompt from your product. Count the tokens. Calculate what 10,000 daily users would cost at GPT-4 pricing. Second, test temperature settings. Take one prompt relevant to your product, run it at temperature 0, temperature zero point 0.7, and temperature 1.5. Compare the outputs side by side. So decide which setting is right for your use case. 3. Map your LLM risk profile. For your product, identify which risks apply: hallucination, cost, data leakage, bias, prompt injection, and reliability. Write one mitigation strategy for each. Okay. And second is what what's next. Okay. Episode 7 is like AI flywheel, how AI products get better with more users, network effects in AI features, and the compounding advantage of AI first products. So don't miss it. Episode 7 is about that. And third, 5 key takeaways from today's session. One is LLMs are sophisticated autocomplete, probability over text, not reasoning. Two, tokens drive everything: cost, speed, and context limits. Three is hallucination is a feature, not a bug. Design product guardrails around it. Four, match the model to the job: open versus closed, big versus small, rag versus fine tuning. Okay. Five, evaluation is your shipping muzzle. So no eval, no confidence, no skill. Okay. If this episode helped you understand LLMs better, subscribe, hit the bell, and drop a comment. What about LLMs still confuses you? Okay, I'll address the top questions in a future episode. So, myself, Pranav Harish, this is AI for Product Managers. I'll see you in the episode 7. Thank you all.